Hey guys, go ahead and add goal 1.4 notes to your table of contents. And in this video, we're going to learn how to predict the correct number of protons, neutrons, and electrons in a given atom using the periodic table. So what that means is, if you have your periodic table in front of you and I give you the name of an element, you should be able to tell me how many protons it has, how many neutrons it has, and how many electrons it has. So let's kind of recap that information. So we know that from what we've learned previously, the two particles that are found in the nucleus of an atom, that's what the center is called, nucleus, um, are neutrons. And remember that neutrons do not have a charge. They are neutral. We also have protons. Protons are positively charged particles in the center. This here is our nucleus. And then surrounding the nucleus are the last particle. We call those electrons. So what we want to be able to do is tell how many of each of those are going to be in any given atom. So how do I know how many protons an element has in its nucleus? This is actually a fairly straightforward thing. Each element has a different number of protons in the nucleus. This is where the atomic number comes from. So in other words, if I know the atomic number of an element, I automatically know how many protons it has in the nucleus. The number of protons is what makes an element that element. So for instance, on this picture that we see here, I'm just going to count the number of protons. We have 1, 2, 3, 4, 5, 6, 7. So if I have a periodic table handy, I can just check that, and I see that number 7 on the periodic table happens to be nitrogen. So this atom over here would be an atom of the element nitrogen. The second one, this time we have 1, 2, 3, 4 protons. If I take a look at the periodic table, I see that number 4, atomic number 4 is beryllium. So this would be an atom of beryllium over here. So the protons are really the first thing that we can tell if we know the name or the symbol of an element. Okay, so now let's talk about the next particle. Oh, first let's back up. I want you to write this down in your notebooks. So the atomic number equals the number of protons. That's an important thing to know. All right, so how do I know how many neutrons an element has in its nucleus? So the neutrons are going to be a little bit trickier than the protons. We kind of went over this before, but let's just recap this. The mass of an element. So remember the mass or the atomic weight, whatever you want to call it, the bigger number in the box on the periodic table. That number is the number of protons plus the number of neutrons. So if I look at this atom here and I count up, let's see, I have 1, 2, 3, 4, 5, 6 protons. That tells me that this is carbon, atomic number 6. And then I add in however many neutrons it has, which this is 1, 2, 3, 4. Okay, so 6 protons plus 4 neutrons means that my mass of this carbon is 10. Okay, so that's a little bit different from what we have on the periodic table. According to our periodic table, the mass of carbon is 12. So there are actually, the masses that you'll see on the periodic table are the most common masses of that element. Remember that the protons tell you what element it is, but not every atom of an element has the same number of neutrons. We call atoms of the same element with different numbers of neutrons, we call them isotopes. So this particular isotope of carbon happens to have a mass of 10, not 12. So it is not the most common form of carbon. Now, how we're going to use the periodic table for this is a little bit more like what you see on the screen now. We can rearrange that equation for mass to read mass minus protons equals the number of neutrons. So in other words, if I know already how many protons the element has, and I know its most common mass, then I can work backwards to figure out how many neutrons it will have in its nucleus. And if you're not given any other information, you can just assume that we're dealing with the most common isotope of that element, or in other words, the mass that's on the periodic table. All right, so electrons. How do I know how many electrons an element has in its electron cloud? That, for us, is solely going to be dependent on the number of protons. Sorry. So for an atom to be overall neutral, protons and electrons must be equal. So think about that for a second. The number of protons must equal the number of electrons. If those are out of balance, then we would have an imbalance of charges. Remember that protons are positive, electrons are negative, those are opposites. We want those opposites to balance each other out. Now there does exist what we call ions, which are charged atoms, but we're not going to worry about those for now. We're going to pretend that every single atom that we encounter has a balance of positives and negatives. So let's do a couple examples here. First example, we're going to take helium. Locate helium on your periodic table, and you'll see that its atomic number is 2 and its mass is 4. So atomic number 2, mass 4. Now going back to what we learned in this video, we know that the atomic number is always equal to the number of protons. So right away, we can say that helium, no matter what kind of isotope it is, has 2 protons. The neutrons are the tricky one, and in this case, we know the mass, and we know how many protons it has, so we're going to work backwards. We're going to do its mass, 4, minus its number of protons, 2, to find the number of neutrons, which in this case is also 2. Now remember, I used the mass of 4. That is the most common isotope. That's the mass listed on the periodic table. I didn't have any information that told me differently, so that's what I'm going to go with. So we have 2 neutrons. Lastly, we have the electrons. These are easy. In our case, we're assuming all atoms to be neutral. So if we have 2 protons, then we also have to have 2 electrons. 2, 2, and 2. Now, it won't always work out like that. For instance, let's use aluminum. If you locate aluminum, Al, on your periodic table, we see that its atomic number is 13, and its mass is 27. We know the number of protons because it's always the same as the atomic number. And actually, we can go ahead and fill that in for electrons too, because protons and electrons are always going to be balanced. Neutrons is the tricky one. Let's take the mass, 27. We're going to subtract however many protons are in the nucleus, so 13. 27 minus 13 gives us 14. So we'll have 14 neutrons in the nucleus.